Hello and welcome to the Slackware AArch vlog. In this episode, I'll show you the vibe coding that I've been doing on this new tool that I've developed called SARE, which stands for Slackware AArch64 Installer Respin. So basically, what's happened is we have a new room in the house, actually a studio that is going to be like a second living room where the kids can go and whatever, and with their friends and stuff, and there'll be a TV in it so that they don't bother us in the rest of the house. Now the thing is that I don't have the way that we do media in our house, and it's always been this way, is that we don't use like a broadcast TV. Haven't done so in like 2 decades. I power it from a computer, and in the house we have a little micro PC which runs Windows 11 on it. I'm a pragmatic person. It doesn't need to run Linux. Windows is easier for me, easier for everyone. It's magic, it takes care of itself, etc, etc. So I use that, and that's great. But the thing is that I don't actually want to buy another Windows license or extend my antivirus subscription to cover it. So I thought instead I'll use an ARM machine to power the TV. So power the TV means basically looking at watching streaming services in a browser. And I thought, why didn't I just get a Raspberry Pi 5 and use that as the machine to drive the TV? Because the Raspberry Pi 5 has a 16GB RAM model, which means that, basically you shouldn't need more than 8 gigs of RAM to run a browser. And 16 gigs should last for quite some time. So I thought, that's okay, that's a good start. The Raspberry Pi 5 is more than sufficient to play videos, and certainly on streaming services. So why not use the Raspberry Pi 5? And it means that I can add support into Slackware AArch64 for the Raspberry Pi 5. At the present time, the official Linux kernel doesn't have adequate support for the Raspberry Pi 5. I don't mind personally using the Raspberry Pi kernel fork, so which is a Slackware. It's a packaged version I've packaged. I've built the kernel from the Raspberry Pi developers kernel fork. So the Raspberry Pi kernel developers repository, their version of the Linux kernel. So I've taken that, built the kernel. I've provided that for the Raspberry Pi 4 for maybe a couple of years already. And then for the Raspberry Pi 5, I built it about a month ago. And so I've done that part of it. And for home, I don't mind doing that, really. In terms of distributing it for Slackware, that's never happening. That's just a red line. We don't ship. No, Slackware is far more of a purist distribution. We try to avoid patching things wherever we can. Sometimes we fall short in it because there was no choice but to patch it. But certainly, there's one thing applying a few patches, quite another to take a completely different fork of the kernel and say and distribute it. That's just not what we do. But for home, I don't mind. So I thought, well, the easiest way of doing it is just writing another tool that modifies the existing Slackware installer. Okay, so that's pretty straightforward. So all we need to do is we've got the kernel already, we just need to replace a few different things in the installer image, change a bit of config, change in packages, and regenerate the installer. That's it. So that's what I've done. Now the thing is that I didn't really want to write the code for this tool. I just wasn't in the mood for it when I started it. I was happy to think about what I needed and document the steps, but I just didn't want to write the code. I was not in the mood at that time. So what I've done is I've used ChatGPT to take my specification and output some code. And so that's what I've been doing with this vibe coding thing. I thought I'll just go along with it and see how I get. In the end, I got it to write the core functionality, but all of the bits for the other parts basically the rest of it I wrote by hand, because I started realizing that I actually quite enjoy writing the code as well, and actually trying to figure out what ChatGPT had built when I was trying to piece it all together, I was like, because I wasn't going to ask ChatGPT to go and write the whole thing, because that means I need to be very prescriptive in what I write, because it does. I mean, I've got to admit, it did a really good job of taking quite loosely defined specification and turning out some code with appropriate comments and appropriate variable names. I was really impressed, actually, because I was pretty sloppy in some of the specification. Whereas when I've done it professionally, I've been asking, I want a feature that does this. I'm very prescriptive about what I want with examples and all sorts of stuff. I was not so prescriptive with ChatGPT, and I was really impressed with what it produced. But understanding what it had done and then trying to put it all together, and I was like, okay. It was my first attempt at doing it. Looking back, I'd probably just write it by hand, or ask it to provide very small, discrete components or discrete blocks of code, but not probably write the entire function, because it's kind of just loses. But anyway, so in this video, I'm just going to show you, walk you through some of what I did with that code, and then finally show you the tool running. And then in the next video, I'll actually show you, we'll boot the image on the Raspberry Pi 4 just to see how it works, and hopefully the whole thing should install without incident. And then once that's done, either Brent can have a go with it, and because he already has a Raspberry Pi 5, he can make a few modifications and see how far he gets. And then I'll buy a Raspberry Pi 5, and then maybe I'll do some videos on setting up the Raspberry Pi 5 with Slackware AArch64 as a media machine. It's quite a long video. I don't expect you to watch all of it, but again, it took much longer than an hour, trust me, to get all this stuff working. But so thank you again to everyone that donates to the project. It will help buy a Raspberry Pi 5, and and let's get into it. Okay, so I have just started more work on SARE, and what I'm doing at the moment is, in addition to uploading the latest Slackware AArch64 stuff, I've taken the spec that I've done. So I specified more or less what the tool needs to do. So, which is basically take the existing Slackware AArch64 all-in-one installer, which is the Slackware installer plus the package set, essentially, and bang it up a little bit, make a few modifications so that it works with the Slackware package of the Raspberry Pi kernel fork. So that's the Raspberry Pi vendor's fork of the Linux kernel. So I need to make a couple of changes because they have a different address name for the serial console and some other stuff. I don't know. There's a few other things that need to change. So make a couple of changes to the Slackware the Slackware AArch64 installer. Replace the kernel package within the Slackware installer. So rather than the Linus Torvalds kernel, we switch out the Slackware package with the Raspberry Pi kernel fork version, and make a few other changes, and then repackage that installer image so that you can then boot the Slackware installer, but this time it boots the Raspberry Pi Linux kernel fork rather than the Linus Torvalds official version of Linux. So that's basically what it does. So I've made a spec file here. It's not entirely in order, it's kind of more of a bit of a brain dump with some kind of structure around it. So I've taken that, and what I've done is I've started copying. The way it's going to work is there's going to be a main function. So there's going to be a main script called SARE, SAIR, which stands for Slackware AArch64 Installer Respinner. I'm getting used to the idea of calling something a spin, because that's what other distributions call it. They have like a desktop spin or a server spin. I don't really understand that usage of the word spin. Does spin actually mean something else? I've got no idea why other distributions refer to a particular image as a spin, because according to this, it just doesn't apply at all. So I don't know why. But anyway, I'm going to go along with that and call it the Slackware AArch64 Installer Respinner. It could also be called Repacker, but because it does also repack it, as in it recompresses it. But whatever. Just go with it. Now, so what I've done is, the way it's going to work is it's going to be similar to everything else in Slackware AArch64, where there's a main process, and then it forks out. It brings in helper scripts. So in the same way as, say, the Raspberry Pi, where is it? Source K Slack. Oh, no, that. Well, yeah, similar to that actually. So you have you have a kernel module loader, and then you have a load kernel module script directory, and then you have individual helpers. So in this case, what will happen is you'll run ser and you'll supply it with some command lines. In this case, we'll say, you know, -- hardware model RPI 4 or 5, and it'll load the helper for that hardware model. And then it'll do everything it needs to do. It'll process it, and then you'll get yourself a Raspberry Pi kernel fork version of the original image. So what I'm doing is I'm taking somewhere that's why. Right, so I'm taking this my specs, and I'm just copying, pasting the relevant parts into the different scripts. So there's going to be ser. This is this script here is going to be the sort of parent, the caller script, and then this one here is going to be a configuration or a helper script. So I'm just currently pasting different things. So the way it's going to work is, if you were to look at the Slackware AArch64 all-in-one installer, like I did here, if you dig into that, you'll see that there are 3 partitions on it. There's one called SLKHWM_BW, which means hardware model bootware. So in the case of the Raspberry Pi, this is where the Raspberry Pi's proprietary kernel, proprietary bootware stuff lives. So this is like the start.elf or elf or whatever it is. I can't remember what it's called. Anyway, that's the Raspberry Pi junk that lives on there. Okay, and then, so that's a FAT, FAT 16 partition or something like that? Yeah, whatever. It's a FAT partition. And then this one is SLK boot. So this is the Slackware /boot partition on the Raspberry Pi. That's where the Linux kernel lives, and the Slackware installer and the DTBs and some other stuff. That's where that lives. And then this in the Slackware AArch64 installer, this, during the installation of Slackware, it converts this partition SLK boot into being the operating system /boot partition. So your SD card remains inserted into the machine, and it becomes part of the OS. That's just how we've done it. You can do it differently actually, but this is the easiest way of doing it, and it's the most portable as well. And then this partition here on the image, on the SD card image or the installer image, SLK ints AIO packages. And this is where the Slackware tree lives. So this is basically the full Slackware AArch64 tree, and all of the package set lives in there. So when you go to install Slackware, it says, hey, I found that you've got the Slackware packages on your SD card. Do you want to install them from there? And you say yes, because then it's really easy. And you just watch it install and it's happy days. So what I'm doing here, now the thing is that this ser isn't just for the Raspberry Pi. At the moment it is, because I don't have any other use for it. But I don't want to just make a tool that just does Raspberry Pi stuff, because there could be in the future other good reasons why you'd need to use a vendor kernel fork. I don't currently have any such usage, as I said, but in the future it might be useful. So I thought, instead of just making a simple tool that just does what I need to do for the Raspberry Pi 5, I thought, why don't I just spend a little bit more time and engineer a tool that can be used for any hardware model. Hence why I'm making it, create it using the plugin system, as I've done for everything else in Slackware AArch64. So now the thing is that not all of the Slackware AArch64 installer images are equal. They all have the same installer image on them, rather they have the same Slackware installer and the same package set, but they're packaged differently. So in other words, if you look at the, so again, I've selected here, this is the, make it a bit bigger for you maybe. This is for the Raspberry Pi 4, although it will also be for the Raspberry Pi 5. But this HWMBW partition does not exist on, say, the Pinebook Pro or the Rock Pro 64's image, or the Honeycomb LX2 either, because this partition here is purely for the Raspberry Pi proprietary bootware, right? So this doesn't exist. This partition doesn't exist on the other hardware models installer image. So I thought, to make it quite simple, but also kind of easy to do, what I want to do is use this config file here for the Raspberry Pi, use it as a reference for the future for other hardware models if you guys ever want to use it or I want to use it. So what I thought I'd do, the main script is going to be quite straightforward. It's just going to have like these global functions. So this is basically the workflow. Create yourself a temporary space, pass the command line options. Oh, I forgot about that. It'll create some temporary space, unpack the init.rd, compress it. It'll also mount the partitions. Now the thing is though, is that I thought what I can do is, inside of each of the hardware model functions, the hardware model helper functions, I can actually just do the same thing. I can copy a little neat trick that I've created for the Slackware kernel module loader. So there you can actually sort of tap into particular points within the Slackware Linux kernel module loader within the operating system initial RAM disk or the init.rd, the Slackware installer init.rd. Hopefully, I don't know if you guys have any idea what I'm talking about. But anyway, you can tap into certain functions. Oh, by the way, if you don't know what I'm talking about, I've created an entire there's 2 YouTube videos that explain what I'm talking about. Anyway, so in a nutshell, there are different points throughout the installer. I suppose I could show you actually, couldn't I? Zcat, CPI. Okay, so basically, if you look here, what I'm talking about, so this is the, when the Linux kernel boots, it loads the initial RAM disk, it unpacks it, and it runs a script called init, okay? Or runs whatever it is that init is. In this case, it's init for the, slightly different in the installer. But anyway, long story short, is if you look here, there is, where is it? Here. So if you look at the bottom, and this is just one place where they are, it says here, fn exists, hwm hook pre-switch root, blah, blah, blah. And it's basically, there's a few of these elsewhere as well, somewhere. I think there's some others up here or something like that. Oh yeah, there's some others inside. Yeah. Okay. Basically, there's a way of, at certain points throughout the boot process, before the operating system proper even boots. So in other words, once you've left the initial bootstrap, which is kind of like this, it boots Linux kernel. It's a very minimal operating system, and then it sets itself up and then pivots into the real OS, or the OS proper as it's called. So there's a couple of tap points that you can tap into throughout this process, and the init script here checks if you've set some functions to tap into it, and if you have, it executes the functions. This is only on the ARM ports. We don't have this in x86. This is basically for me, well, it's really for Brent actually. I created them mostly for him to help onboard new hardware models. But it's also very good useful for me as well for troubleshooting and stuff like that. Now, where was I? Pop D. So, nano specs. So, now, so I've taken that same kind of, that feature, and I've decided to do it this way around. So if I look, what I'm going to do is the main script here, SAR, is going to load in the helper script. So it'll load this script here, and it's going to check to see whether the image, the installer image that you supply, it'll scan the image, look for the file, look for the partition names, and then if you have a handler, a functional, which is just a bash function, so I'm calling it part_handler. If you have a function called this, part handler, followed by the name of one of the partitions, well, the file system labels actually. So if you have a partition handler, I suppose I could call it FS handler actually. You're right. It shouldn't be part, because it's not partition handler. Well, it kind of is, isn't it? Because it's a. Well, let's call it FS handler because it's shorter anyway that way. Okay, so they're called FS handlers, right? So if you've got, if you have a file system handler for any of these here, whether any of these labels, it will mount the partition with the file system. It'll mount the file system. Then it will call your function. And at that point, for example, in this here, we will modify the X Linux config, which is U-boot's boot configuration. It'll modify that with a couple of changes for the Raspberry Pi kernel fork. It'll also, in this case, it will go in, it'll enter into the Slackware package directory, and it'll delete the kernel, the regular Linus Torvalds Slackware kernel, and it will replace it with the kernel fork kernel. So I've got to write all the code that does this, obviously. There's nothing there right now. But that's one of the things I'm going to do. Now, the first thing is I'm just using ChatGPT because ordinarily I would just sit and write all this code, but I don't want to spend loads of time writing the code. I've decided, I know what I want to do, what I want to achieve. So I've just decided to use, because originally I got this whole idea that I'd just write a spec file and say, hey, ChatGPT, go write me some code. But then I thought, it's going to come up with, like, I'm going to have to be very specific. I'm going to have to be incredibly prescriptive in order to get anything useful, I think. I mean, unless somehow ChatGPT can just happens to do, come out with something amazing, I'm going to have to, put a bit of work into it anyway. So I figured all I need to do is just collect up what I need to actually achieve out of this script, the main functions. I know all this stuff, it's in my head, I just need to get it out. And then I'll write the code, get the structure right, and just tell ChatGPT, go and write me some code to do this, and then I'll modify it. The first thing is I thought, I'm not feeling particularly creative today. So one of the things we want to do is to delete all of the, here it is to delete the, why do I even need to do this? Unpack. Oh yeah, okay. So the first thing I need to do is delete the existing Slackware Linux kernel, the DTBs, which are the device tree blobs, and the installer image from the /boot partition. So I thought, okay, because these names are universal, plus the fact that this script will be used with the official Slackware AArch64 installer image. That means that all these file names are standard. So I can, instead of just, basically I can make a generic function in the main script, the main tool, that just deletes all this stuff. So I don't need to replicate it in any of the other helper scripts. And I thought, I don't even know what to call it. I'm just not feeling, I've had a few coffees, but I'm not feeling particularly creative right now, at least in terms of naming things. So I thought, I'll just ask ChatGPT. So I just said, look, I want to make a function that purges the Linux kernel, the initRD, and blah, blah, blah. What shall I call it? And ChatGPT says purge kernel artifacts and a few other things. So to me, that seems like a good idea. So I'm just going to call it kernel artifacts, right? And then I'm going to, what I'm going to do? Do you know what I'm going to do? Let's just see what happens if I do this. Right. Don't want that. I'm not even writing this properly. Let's see what it does. Okay, interesting. Yeah. Okay. Okay, that's cool. Right, so let's just take that. I'll modify that up a little bit. But you can see that this, you know, we don't need the. I thought artifacts was a. Huh? I thought artifacts had an I in it. I didn't know that. I've been spelling it. What? Is that actually correct? Is it really? Artifacts is written with. I've never seen that before. Oh, that's what I thought. Artifacts. Ah, there's two spellings of it. Okay, that's why. We'll use the spelling that I'm familiar with. So there we go. That's that bit written. Cool. Right, what's next? So anyway, you can get the idea of what I'm doing here, right? So that basically, that's going to be purge kernel artifacts. Oh, mind you, I suppose it needs to take a. Does it really though? Does it need to change? Does it need to? Well. Yeah. One. Okay. That should work. Yeah, so basically it needs to take a parameter though, because it's, oh yeah, and then it needs to pop D as well. Okay, yeah, so it needs to take a parameter, which is a directory, cd into it, and then delete the stuff, and then exit, or change directory back to the original previous directory. Okay, cool. So we have done that. Okay. So the SARE script would be purge kernel artifacts. So we call that here, bang that in there. Da, da. Oh, actually, that's going to be later. Okay, so I'm not going to bore you with all of this, and then that needs to be whatever. I'll come up with that later. So yeah, this needs to have a parameter. At the moment, I don't know what this variable will be called because I haven't got that far yet. At the moment, I'm not even thinking. I'm just doing stuff, not even having a single conscious thought about what I'm doing. Because I've got my spec files. I'm just allowing myself to just code this with the help of ChatGPT to offload a bit of the labor. So eventually this will have a mount point to something /boot, I guess, or whatever. I'll figure that out later. Yeah. So yeah, that's what I'm doing really. And what else do we need to do? Unpack the kernel. Why do we need to do that? Copy. Oh yeah, so we need to unpack the. Right, yes, okay. So here, like this function, what I'm planning on doing is, because I don't want to have to recreate or create the latest, create new versions of the Slackware installer just to do this. What I thought I'd do is have this tool, SARE, update certain parts of the installer. So for example, the installer image. So for example, obviously it's going to replace the kernel package with the Raspberry Pi kernel fork version. But I thought also I'd have it replace the kernel firmware package with the latest version in the Slackware tree. And likewise, the hardware model. Yes. Update the... what's it called again? What's the package called? Hardware model. Oh, that's the one, yeah. That one package. So then that needs to be replaced there. Okay, so yeah. So then also replace this Slackware package here, or update it rather, with the latest version, because that contains U-boot and it contains the latest Raspberry Pi firmware from the Raspberry Pi developers website. There's a few other things as well. So you can get the idea anyway what I'm doing here. Yeah, and so I just need to fill this out and start doing it like that. And so slowly but surely I will use ChatGPT to build some of this stuff, and then we end up with a script. So now I've just been working on this a little bit more. So we've got a tool to, again, I haven't figured this part out yet, but I'll get there. This is the thing I'm working on. I'm just whatever comes to mind. Instead of like trying to do it in what seems like a logical order, I'm just doing whatever comes up in my mind, and I'll trust myself to just figure it all out. But without having to put as much effort in as I used to do. So what I want to do here, I need to extract the kernel, the initRD, DTB, and some other stuff from the Slackware, the Raspberry Pi kernel fork Slackware package. So I'd use tar to do that, but I don't want to have to unpack more than I need, because if you look in the installer, for example, if you look here, this one, so this is the package. So this is the Raspberry Pi kernel fork package for Slackware. Okay, so if you look here, what we want is this here. We want the Linux kernel, which is this, the system map. The system.map contains the symbol table of the kernel, so we will copy that as well, and the kernel config and the device tree blobs, the Slackware installer, and that's all we need. I don't think we need boot details either, actually, because that is, no, we don't need that. Right, so yeah, we just need those files. And what else did I put? Do we need anything else? Oh, the install directory, but we only need the install. Yeah. So what I've done, we need to. So at this point, we would have deleted the standard Slackware stuff, and then we need to unpack the kernel and then extract just the parts that we want. Because if you look in here, you'll see that these are the directories, etc., lib, espin, and user. We don't need any of that stuff. So I only want to just extract the parts that I want. So we can easily do that with tar. But instead of me remembering how to do it, I just told ChatGPT to do it instead. And if the archive does contain it, which it does, so, but let's try this out for size. So if I do q tar xf, right. Fact, let's unpack, right. So then we want to do this, like that. That's quite long, isn't it? Okay, xf, yeah, okay. Right, so we want that, and then also we want install do /sh. Okay, so let's give that a run. Actually, just double check that doesn't contain anything utterly ridiculous before I run it as root. We're in here, so no, it's fine. Okay, so sh /unpack. Right. Okay. Okay. But then we have that stuff. That's good. There should be tar tvvf. Right, so there should be the install directory somewhere, which there is. So why does it not like that? I did it copied the yes, done that. Okay. What didn't it like about that? What was it complaining about again? No, let's do it again. Oh, hang on. Did I just do it? Did I do something silly? Oh, yeah. I missed the backslash. There we go. Right, so if we delete this stuff here and do that again, we should now have a doInst script. Perfect. Right. So that works. So we can use that. Right, so we'll call that, what did I call that here? Function setup kernel artifacts. Yeah, okay. So that needs to push D into string 1, return 1, and then pop D. Okay, and then so it's going to unpack. I suppose I should check the yeah, string 2. So that would, for example, e.g. Oh, I'll take the whole thing actually. Oh, well, actually, it's there, isn't it? So, okay. String 2. Okay, so $2 is going to, or parameter 2 is going to be the name of the kernel package. String 2 equals that. Wildcards, da 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 da. Right, so then all we need to do is run the, so where did the other thing go? Got too many windows going on. Is that honey? No, that's honey. Not there. Specs file. Ah, there it is. Right. So we get that. Then what we need to do, so we've got these, but these are versioned, as you can see, right? And what we want is the unversioned. We need a symlink that's unversioned because all of the config files refer to unversioned artifacts, or like so. In other words, image. Image arm v8 system.map config. So we need all the config refers to static file names, and we accomplish that using symlinks, symbolic links. So ordinarily, when you install the kernel, if we look in, let's look in /boot, for example, this is what I'm talking about here. We need to create these symlinks. When these cyan-colored symlinks, when you install the Slackware package, it sets these symlinks up for you. But we're not installing the package. We're just we're extracting data from the package using tar. So what I need to do is to create these symlinks. These symlinks are installed into here. Well, in the install directory of the package, which is wiped after the package is installed. So what we've done is we've extracted it directly here like this. And if you look here, if you look at the top, here's the code that creates these symlinks. So all I need to do is to run that code. So the way to do that is like this, which I organized earlier. So if we just grep for that, yeah, grep like that. Oh, pardon me. We've removed the install directory, so we do that, right? That's what we want to do. And then all you need to do is do bash like that, and we should end up with a bunch of symlinks. Cool, yeah, done. So we just need to do that, do a bit like this, do a bit of that. We don't need the install script anymore, I don't think. Cool, right, so there we set up the kernel artifacts. Push D1 return. So fail if we can't enter the directory, unpack. I won't bother checking if the file exists. We'll do these tests earlier on. So when the user supplies the kernel file as a parameter, well, I haven't actually figured out whether I'm going to do that or not. I might specify that kernel stuff in here. I haven't decided how I'm going to do that yet. Anyway, it doesn't matter. I just need to get the main functions done. So we'll unpack. We'll make sure that all this stuff exists before we try and do anything with it. So we'll unpack that, unpack the data, create the symlinks, delete the post-install script because we don't need it anymore, and then cd out of it. Cool. Without leaving any residue or extra residue, or actually leaving any residue, any temporary residue at all. Cool. So yeah, Okay, so I'm now looking at unpacking the Slackware installer. So that is the initRD within the Slackware installer in the AIO image. So I want to unpack that into a temporary directory, and I already know how to unpack it because I do it all the time, but I didn't know that there was a -D option to unpack it into a different target directory. So I just asked ChatGPT, unpack this, but into a different directory, not the present working directory. And apparently there is a -D option, capital D, I didn't know about that, to unpack it elsewhere. So this is, when I previously do all of this by hand, I would either know how to do it anyway, or I just read the man page, because often there are new versions, there are new releases of the tools that add extra functionality. But unless I don't keep on top of those things unless I actually come to use them and wonder, oh, I wonder if there's a better way of doing this that's included within the tool these days, rather than piping it into something and whatever. So as it turns out, there is a -D option. By the way, this is a really good use of ChatGPT, because again, like I just said, unless you keep on top of these tools, you don't know what new features they have. So you end up doing things the old way, and you end up writing more code than you need to anymore. So it's really quite cool, actually. So yeah, it's provided me with this -D option, and that now I'm writing a function called unpack slk installer. Now, inside of the Slackware installer image is obviously the Slackware installer, the actual CPIO archive. It's a compressed CPIO archive. Now, there's no good reason to ever use an old version of the Slackware installer. So that's when you boot the installer, everything that gets displayed on the screen, all of that stuff, that's the installer. There is no good reason to ever use an old version of that. There just isn't, believe me. So in this function here, purge kernel artifacts, we are actually wiping the Slackware. We're deleting the Slackware installer, because the Slackware installer is called initRD-. Oh, actually, that should probably be called. Let me just double check that actually. Install initRD. No, it's fine. Yeah. So the installer is this initRD arm v8. So yeah, so this would be really quite old. It's usually several months out of, well, at least 2 or 3 months out of date, because I only update the installer images for current once every few months, right? Now, so at that point, the Slackware installer, I mean, if you look at the Slackware 64 current source installer changelog, you can see, there are updates to it. So we're currently in August, at the end of August, and there have been updates even in June, right? So it does get updated, sometimes by me. There's me adding whatever that was. Oh, some fonts for the virtualization in VMware on the Mac. Yeah, so you do get updates, and again, there's no reason to ever use an old version of the installer. So what we're going to do is we're going to unpack the Slackware installer from the current tree. So inside of Slackware AArch64 current, which is Slackware AArch64, there is a directory called installer. Okay, so there's the Slackware AArch64 current directory, and then in the top level of it, you have a directory called installer. This, I mean, there is actually a README. I don't know what it says. Oh, it tells you exactly what it is. Yeah, I forgot I've written that. Slackware AArch64 and ARM is pretty well documented. Well, as is Slackware. If you look around, you'll see lots of little READMEs dotted around. So this explains what's going on here. And you'll see this installer image can't be used to install Slackware. That means you can't just boot that thing. I mean, well, no, yeah, I'm not going to get into that. Anyway, but this actual image here this image itself is incorporated into the SD card images that you download and DD to your SD card. Now what we're going to do, because this image is just sitting there ready for the taking, we've already deleted the installer image from we're starting to get mixed up with terms here. So we've deleted this initRD. Let's use a different term. We've deleted the initRD, which is the Slackware installer. We've deleted that from the Slackware installer image for the SD card. So we've got different levels of images going on here. And now we're going to unpack the this version of the image here, and what we need to do after that is delete the kernel module. So we need to replace the existing kernel modules, which are from the Slackware kernel package that was available when that Slackware installer image was created. We need to delete those and replace them with the kernel modules from the Raspberry Pi kernel fork package. So that's what we're going to do there. So I'm just making this little generic or global routine to do that. Okay. So we're on the home stretch now. I've pretty much completed the entire tool, and I could just show you kind of, well, I'll do it here actually. So at the moment it's not available because it's not finished. So here it is. So I've just to recap. So I've been using ChatGPT. I've used it to build out most of the core functionality of the tool because I didn't want to write it by hand. And I started off with some of the simple stuff here. So I thought I'll just get it to produce a sort of, a help function. So it tells you what the command line operators are, and I didn't really provide it much help here. I did provide it what the names of the parameters were because I didn't want it to invent its own, but based on the context of the project in ChatGPT, it kind of figured out the messages, so it figured out the help text. I've modified it a little bit, but other than that, it figured it out itself, and it organized it all like this. So it said what the flags were, optional parameters, and parameters that are required, and whether they're just flags or they require a parameter. Command line options. So for example, there are required command line options to use the tool. So you have to specify an existing AIO image, and you have to specify an output file name. And obviously that requires a parameter because you have to supply the command line option and then provide the parameter being the image file. Okay, and then we have to provide the hardware model. So in this case, at the moment, it's just the Raspberry Pi 4. And then there are some optional parameters. Sorry, I'm getting all mixed up here. There are optional command line options, which also require a parameter, but they're not required to run the tool. You can just change a few settings. And then you've just got some extra flags which are completely optional and don't require any parameters. So I got it to build that out. That was all pretty good. Hold on, let me scroll down a little bit. So it built the help text and it built this as well. So I told it to build me the command line parsing code, because ordinarily, I mean, all I do is I open up one of my existing projects and I just copy this and modify it. There's nothing special or unique at all about any of this stuff. It requires no thought at all. I just copy paste it and then modify the parameter names, and that's it. Simple stuff. So I got it to write that for me based on what the parameters were, and it also it created all of the variable names as well, and I liked pretty much everything I saw, so I just took it and used it. It's slightly different. The way it's organized it is different to how I previously wrote it by hand in my other scripts, but nothing that was nothing that I found objectionable, so I just left it as it is. And it's got all of the sanity sanity testing here to make sure you've actually specified some parameters and stuff like that, and things like that. So that's all pretty straightforward. So yeah, I've got let me just scroll back up. So I've got ChatGPT to write the majority of these functions. It's interesting because it's the code that it's created is not my style. Some of it is, but I mean, this is my style, where you don't use if statements. You just pipe it, you just use a double pipe symbol. to mean or. You know, if this doesn't work, then do this kind of thing. Some of it's my style, some of it's not. Like this is not my style at all. What's the word? Not collapse them all. I not really concatenate either. I've forgotten the word for it now. But basically, I would just do -PM700. You don't need to separate out the command line operators there. There is a word for that, and it begins with C. It's not concatenate. It's not condense. It's something. Anyway, there is a word for that. But anyway, that's not my style. But I thought, you know, I'm just going to leave it. I'm not going to. The whole point of this is to try and minimize the effort here, and it works. The code works. It's just quite verbose in some ways. And actually, as I was testing it, I encountered a bug where when the AIO image is mounted and the variable the array of the data structure is populated with the file system names and the mount points, sometimes it wouldn't mount some of the available file systems. I don't know why. I don't know actually what the problem is. So I thought, well, I'm not going to debug ChatGPT's code because I didn't write the code, even though I can read it and I can very easily ascertain what it's doing. I didn't write this code. So for me mentally it's not, I don't do this as a profession. I don't write code. I mean, I have to some degree as a sysadmin, like you could say it's professional because systems would be running on the code that I wrote. But it's not something that I do professionally. So I don't have an easy way in my mind of just looking at it and going, yeah, okay, I can probably figure it out. If I wrote it by hand, that's a different story. I can much more easily debug code that I wrote. But I looked at it, I couldn't see what the problem is. It may not even be a bug in the code. It might be just some weird thing going on outside of it. Anyway, so I thought, let's get ChatGPT. I thought to myself, I'll write some. I'll just write in a safety check to make sure that all of the expected file systems have been mounted. So I was about to. In my head, I envisaged 5 lines of code maximum, and I thought, hold on, why don't I just get ChatGPT to write that as well? So I explained what had happened to ChatGPT, told it what I wanted, and it expanded the function to include a safety check. So in my mind, I thought there'd be 5 lines. However, here we go. So it's load. It opens up the AIO installer up here somewhere. Creates an array. It mounts the file system. It mounts the file systems in the image. Makes an array which can be referred to later by the handler functions. And the array just contains the file system name and the mount point. That's it. But again, some of them weren't being mounted. I don't know why. So I said, create a safety check. So here it's created a safety check. And it's like this long. And I was just thinking, it's not how I would do this. I would have done this in a few lines. But I thought, well, you know what? I'm not going to rewrite this just for the sake of having less code. I'll just use it. And a safety check, it works. So yeah, I don't know how I go about it. You know, honestly, if I actually wanted to really modify this in the future, I actually would probably just rewrite it. Because looking at this, if I wanted to change this, I would just be like, okay, you know, I don't need to it's my code. I own this now, so I don't need to go in and I don't need to just make little changes. I'd just rewrite the whole thing by hand because it would actually be easier for me. Because in my head, I know how it works. So I just, you know. But anyway, it works fine. The safety check has come in handy on already several occasions where I've been testing the tool. So I'm happy with it. It does work, but it's really quite verbose. But anyway, so yeah, I've got most of the core functionality of the tool is all present in this main script called SARE. We're going to be using the Slackware ARM development kit because we've got some variables populated inside of there, which I'm going to be using to collect parts of the, you know, to be able to collect packages and some other stuff that's part of either part of the Slackware tree or outside of the Slackware tree, and that's all configured in the dev kit. So we don't need to reinvent any of the wheel or anything like that. So yeah, this is the main script. Well, I'm not going to walk all through this. Once this is available, I'll let you guys know if you want to have a look at it, and I'll do that in another video. So yeah, that's all split out, and then we've got like the main business logic, and which just calls the functions basically. So so we've got that. That's the main script, and then inside of ser.conf is where the hardware model helper scripts live. So for this one, this is just for the RPI 4 at the moment, but it'll always be for the RPI 4. When I come to create a version of this for the Raspberry Pi 5, I'll just copy this and change the settings, because that's the easiest thing to do. So yeah, in here, again, the way it's split up is we've got an initialization function which just sets a bunch of variables that will be used by the other functions and performs some sanity checking. In this case, it just sets up where the kernel fork directory is. So it's the directory that contains the Raspberry Pi kernel fork Slackware packages. Checks a few other things, finds which version of U-boot we want to use, and some others, and hardware model bootware package that contains the Raspberry Pi firmware and U-boot and some other bits, and the DTBs and stuff like that. So you've got this initialization function, and then we have the handler. So we have a handler to handle each file system within the AIO image, the Slackware installer image. And then it's up to the parent script to call these functions if it finds them available. So so for example, this one here, the hardware model bootware, this is the FAT32 or FAT16 or whatever it is, FAT partition that contains the Raspberry Pi proprietary bootloader and all that stuff. So basically that just, what does it do? Installs the latest versions of the Raspberry Pi proprietary bootloader config file. So it copies those. It updates the bootware, so it installs the latest Raspberry Pi proprietary bootloader. It installs that. It updates U-boot to the latest version as well, and then updates the device tree blobs. And what else does it do? And of course the kernel as well. It replaces the standard Slackware official Linux Torvalds kernel with the Raspberry Pi kernel fork. That's what it does. And then within the boot partition, or the boot file system, what does that do? So that unpacks, so that deletes the existing kernel, DTBs and installer, unpacks the kernel. What does it do? Oh yeah, creates some symlinks and stuff like that. And then we unpack, it deletes the existing installer, then it copies or unpacks the latest version of the Slackware installer, unpacks it, replaces the kernel modules with the versions of the kernel modules from the Raspberry Pi kernel fork package. Doesn't do any filtering at the moment because there's no point. So it doesn't delete anything, any excessive stuff. I could make it, but there's no point. Rebuilds the kernel module dependency map, creates a flag within the installer to say, hey, this is the Raspberry Pi kernel fork variant, and then repacks it. And then once it's repacked it modifies the kernel Linux. It modifies the Linux kernel command line settings within U-boot. So it just needs to make a few changes to support the Raspberry Pi kernel, which is these changes here. It adds those in so that the what is it actually? Oh, it changes the console settings, yeah, basically. Then what else does it do? Yeah, so that's it for the boot partition. And then finally, all it does is it just it changes into the directory or the file system within the installer that contains the packages that we're actually going to install. So it basically just refreshes, it just updates them to the latest version. Sorry, it updates some of them to the latest version. So for example, it will remove obviously the kernel and replace it with the Raspberry Pi kernel fork. It will then create a text description file for that package. So it will create, in other words, the TXT version of the package. And that just means that it installs faster, because if the install package can't, if the Slackware package tool can't find a .txt file, it doesn't know how to describe the package. So it will then uncompress the package, extract the file, the package description, then display it, then it'll unpack the package again to install it, which is quite an overhead. So we just regenerate that package description ahead of time. Then it refreshes the kernel firmware package with the latest version. It also does the same with the kernel, with the Raspberry Pi hardware model package, which contains the bootware, DTBs, and Raspberry Pi firmware stuff, all that stuff. It updates that. And finally, it updates the kernel source package as well, replacing it with the Raspberry Pi kernel fork version. And that's all it does. So it just updates a few of the packages, because the reason for that is because the AIO Slackware installer images are usually quite a few months out of date, and because I don't update them that often because there's no need. But I obviously want to, when I produce this, I want the latest versions of the firmware. I need a different kernel anyway. I may as well have the latest kernel firmware. So when we do, I mean, those are the core things that I want to update. I could update other packages here as well, but there's no point. There's no need to do that. Those can be updated after the OS has been installed. And then finally, we have a hardware finalization or a hardware model finalization routine, but it's undefined because I can't think of any use case for it. But if you did define it, SARE would call it. So it SARE detects which functions you've defined and then calls them if they've been defined. It doesn't error out, for example, if you don't have to go and do this like that and just go, oh, I've defined it, but it doesn't do anything. You can just leave it undefined and SARE will be fine with that. Right, okay, so that's the tool. Now, let's show you it in action. So if I do this, I'm running it in debug mode. So it's going to pause after every step. So normally what you do is, so -S is supplying it the AIO image. So these are the official Slackware AArch64 installer images. Now, ordinarily, these are shipped as XZ compressed images or LZMA compressed images. SARE will accept an XZ compressed image and it will decompress it. But for testing purposes, that just adds time to the whole testing process. So I've decompressed it in advance, and I'm just supplying SARE the uncompressed version because saves me time. But usually I will just supply it the latest version that's compressed, and it will take care of the whole thing. You can also tell SARE to recompress the new version of the image that you've just built with this tool, but that takes absolutely ages to recompress. So I'm not going to be doing that. I don't see myself doing that. I'll use SARE to build the image, and I'll just directly write the image to an SD card. If I end up publishing any of these images, which I might do if you guys are interested in it, when I get around to creating a Raspberry Pi version of this, and we need to, because the Linux Torvalds kernel still doesn't adequately support the Raspberry Pi 5, then I may well provide these images, and I'll just bung them up on the FTP site and in the experimental directory, and I'll announce it, and those will be compressed. But yeah, other than that. Yeah, so that's the source image. This is the destination image, and then that's the hardware model. Okay, so so it's just showing you. In this instance, we can see all of the directories have been mounted. Oh, rather, the file systems have been mounted, not the directories. So here's the SLK boot partition. That's been mounted here. Here's the packages partition. That's been mounted there. Here's the hardware model bootware. That's the Raspberry Pi proprietary stuff. That's been mounted here. So if we now look, if I drag in the can't think there's a can't make that bigger, can I? And that's, oh yeah, I can. Let's try and make it a bit bigger. Oh, I just pick one of the big ones. I think that's probably good. Oh, it's not that big actually, is it? Is there a bigger one? That one? That's like even worse. I thought that that would be big. No. Okay. I think. Oh, there we go. That'll do. Okay, so I'll show you. So the way I've tested this, if I go to /temp slk boot like that. Okay. So what I've done here is I can see the dates. So we've got the kernel image April the 1st. So this was when the AIO image was last updated, more or less. It's not quite right, but more or less. And then if I look at slk AIO packages, Slackware A kernel, for example. Oh yeah, because it's not in there, that's why. Slackware AArch64 kernel third. Okay. So just to get an idea, all I wanted to do was just validate have my data files been updated or not, and then finally slk. Okay, and again we can see that this stuff is quite old. Right, so then we run this. So we're running the first file system handler, which is the /boot partition. So if I, which is this one. So that's just currently repacking the installer. So you can see it's unpacked the installer, unpacked the kernel modules. It's then updated all that stuff. It's rebuilt the kernel module dependency map, and then it just repacks the installer with all of the updates. And then we should see, oh, it's this one. So if I do here, yeah, now you can see, so we are in December the 18th, I think, sorry, September the 18th, yep. So we can see we have a new kernel. It's also the latest version of the kernel for the Raspberry Pi, which is this one, which I built the other day. And all of these files have been refreshed, so that's good. We should also see, hopefully, I think that, ooh, that's got an E on, why does that have an E on the end? That's interesting, I've not seen that before. Okay, let's just have a look at that. There must be some, I'll look at that in a second. Yeah, okay, so we can see that it's added these required Raspberry Pi kernel fork parameters. That seems okay, yeah. Okay, cool, that's fine. I'll check that thing. I think that's just an artifact of using sed actually, we'll have to check that. Right, so that's fine, done that. Next, we're going to run the packages one. So the handler to update the packages. So you can see it's removed the kernels. Yeah, well, so this is the old kernel that's currently in the Slackware AArch64 installer image. So it's removed that. It's slackdtext is creating new package descriptions for the replacement files. So if we now look at ls, there we go. Yeah, and we can see that there's a new version of the kernel firmware, which is dated a few days ago, and the kernel itself was built, yes, yesterday, in fact. Yeah, so you can see we've actually got the Raspberry Pi kernel fork kernel. You can see it labeled here with RPI 4. So we've replaced the kernel within the package set, and presumably I didn't check this, but we should probably check that as well. Yeah, same with the kernel source. So that's done. And then what's next? Hardware model bootware. That is here. ls. Oops, ls. Okay, so this is the Raspberry Pi proprietary stuff, more or less. So you can see we've updated that as well. Need my key map. I've got a bad key map. Is it US? Yeah. Okay. So yeah, we can see that we've got all of this stuff has been updated with files that were created only a few days ago. So these are from the latest Raspberry Pi kernel fork package. Cool. Yeah, awesome. So it seems to work. Then we just press enter. Oh, wait, I need to leave that directory, otherwise it won't umount. So do that. It's fine. It's just because I was in that directory. Although, yeah, this. Oh, I might be. Well, it shouldn't be. See, I'm not in it anymore. So, anyway, so if I try and mount that now. No. Oh, it's the other one. That's why. It's like. Oh. That's okay. Is that big? Okay. Okay, must be. Oh, never mind. I must be in it in some other shell. Anyway, so, oh, it could be that I've got another one open here or something like that. Quite possibly. No, it's not actually. Okay. Okay, there we go. Right. Cool. Yeah, so anyway, that's fine. But basically, that works fine. So if I just take out the dash debug now, just run it without debug mode, and that should just walk its way through. So once that's complete, well, it is complete as far as I can tell. The next thing is to test it, but I'll leave that for another day, or maybe another week or something. Look, there we go, look. So this is the safety check. I don't know why it does that. So there should be, so this is quite cool actually. I don't know what's actually causing this bug, but if I do it again, so there isn't any SES stuff mounted. So if I do it again, usually it works on the second go. But yeah, I need to look into that. I don't know if it's a bug in the code ChatGPT's created or something else outside of it. I don't know. But anyway, the safety check works. Yeah, it's weird. But yeah. So yeah, once this is done, yeah, there we go. It's fine. It's strange. Yeah, so once this is done, I'll take this new image, put it on an SD card, and then test it, and that'll be for the next video, I think. All right, guys. Well, I hope you've enjoyed that, and I'll see you in the next video. Take care. Bye-bye.